So was there any question that was tough? Won't say everything was tough. So just in 15 minutes, can we have a quick discussion of this paper? So I'm just going to share the idea. I'm assuming everybody would have seen and solved it, right? So that's why can I go a little fast? No. So tan inverse of x divided by root of a square minus x square. So whenever you have a square minus x square, what will you substitute x as? A sin theta or a cos theta. In this problem, what would you prefer? You'll prefer a sin theta because you will have sin divided by cos. So the tan inverse of something will get eliminated. Tan will get eliminated. That also second. So tan inverse of what will you get? You will get a sin theta divided by a cos theta. Am I right? So a and a will get cancelled. Tan inverse of tan theta will give you theta. But what is theta? Theta is sin inverse of x by a. So the answer for the first one is tan inverse of x divided by root of a square minus x square is actually sin inverse of x by a. Or if you want to take a triangle and then solve, you can do that. Okay. What about the principal value of cosecant inverse of minus root 2? So it is pi minus, sorry, not pi minus, minus cosecant inverse root 2 minus pi by 4. I'm directly writing the answer. Okay. Third one, write the value of the expression tan of sin x plus cos, sin inverse x plus cos inverse x divided by 2. Irrespective of whatever is the value of x, I can say sin inverse x plus cos inverse x is always pi by 2. So I'll get tan of pi by 2 divided by 2. What will I get? Tan of pi by 4, which will give me a 1. Right? Fourth one, cot inverse of minus x in terms of cot inverse of x. So it is pi minus cot inverse of x. That's what I expect. So cot inverse of minus x is equal to pi minus of cot inverse x. Why did I write pi minus? Because it is an inverse trigonometric function whose principal value lies between 0 to pi. So 0 to pi, whatever, whenever you have a negative value inside the inverse, you should write it as pi minus positive value. So pi minus cot inverse x. Secant inverse of secant pi by 3. Directly you can say pi by 3. Because for secant inverse, what is the principal value? 0 to pi. So pi by 3 is there. Sixth one, sine of cos inverse pi by 13. So sine of cos inverse pi by 13 is sine inverse of cos pi, 12 and 13 are Pythagorean triplets. Right? So sine of sine inverse of this is 12 by 13. You write like this. You wrote it. Express tan inverse of root of 1 minus cos x by 1 plus cos x in the simplest form. So I'll get tan inverse of 1 minus cos x can be written as 2 sin square x by 2. So square root of 2 sin square x by 2 divided by 2 cos square x by 2. 2 and 2 will have it cancelled. I'll be left out with tan inverse of root of tan x by 2, which is tan x by 2. Answer will be x by 2. Okay. Express tan inverse of cos x by 1 minus sin x in the simplest form. Okay. Tan inverse of cos x by 1 minus sin x in the simplest form. So this should be equal to tan inverse of cos x. I can write it as cos square x by 2. 1 minus tan square. You want to write it like that? Okay. 1 minus tan square x by 2. This is also a right way. See, there are two ways to solve this problem. One is cos x, you will write it as cos square x by 2 minus sin square x by 2 divided by 1 minus sin x, you will write it as cos x by 2 minus sin x by 2 the whole square. Yeah. Because 1 can be written as cos square x by 2 plus sin square x by 2. And sin x can be written as minus 2 sin x by 2 cos x by 2. Is everyone able to understand? To some extent. How many of you didn't write the test? Not written. Others have written. So you also didn't write. Okay. So I hope that one is clear, right? That is one way of solving, or you can go with 1 minus tan square x by 2 divided by 1 plus tan square x by 2 divided by 2 tan x by 2 divided by 1 plus tan square x by 2. 1 minus 2 tan x by 2. No. 1 minus 2 tan x by 2 divided by 1 plus tan square x by 2. Right. So I'll get tan inverse of 1 minus tan square x by 2 divided by 1 plus tan square x by 2 divided by, when I take LCM, what will I get? I'll get 1 minus tan x by 2 the whole square. In the numerator, yeah. Because look at the terms now, I'll get 1 plus tan square x by 2 minus 2 tan x by 2. Is it not of the format a square plus b square minus 2ab? So a minus b the whole square, the whole divided by 1 plus tan square x by 2. So this and this are gone. It's the same logic again. Tan inverse of, I can write this as 1 minus tan x by 2 into 1 plus tan x by 2 divided by 1 minus tan x by 2 the whole square. Cancel this and this. So you're left out with tan inverse of 1 plus tan x by 2 by 1 minus tan x by 2. So this will be tan inverse of tan of pi by 4 plus x by 2. So answer will be, you can go with the other method. Which one? Previous problem, 7th one. We'll get the same answer. So I hope it is clear, no? So anyway, solution will also be available in the tab, the study materials tab. But I'm also trying to explain. 9th one, sin inverse x minus cos inverse x is pi by 6. Then find the value of x. Sin inverse x minus cos inverse x is pi by 6. Find the value of x. We know that sin inverse x plus cos inverse x is pi by 2. So add both, you will get 2 sin inverse x is equal to pi by 6 plus pi by 2. How much is it? 90 plus 30, 2 pi by 3. So 2 and 2 will get cancelled, which implies sin inverse x is pi by 3 and x will be equal to sin pi by 3, which is root 3 by 2. Right? So this is 9th one. What about the 10th one? Tan inverse x minus cot inverse x is tan inverse of 1 by root 3. Tan inverse x minus cot inverse x is equal to tan inverse of 1 by root 3. But tan inverse of 1 by root 3 is a known value. How much is that? Pi by 6. Then what about this thing? Tan inverse x plus cot inverse x will be pi by 2. When you add both, you will get 2 tan inverse x is equal to pi by 2 plus pi by 6, which will give you 2 pi by 3. So tan inverse x is equal to pi by 3, which implies x is equal to tan pi by 3, which is a root. So previous problem was sin pi by 3. This one is tan pi by 3. So this is for the 10th one. 11th one is tan inverse x plus 2 cot inverse x is 2 pi by 3. Tan inverse x plus 2 cot inverse x is 2 pi by 3. Find x. How to solve? It's very simple actually. So tan inverse x, you can write it as pi by 2 minus cot inverse x. Substitute it here. So pi by 2 minus cot inverse x plus 2 cot inverse x is equal to 2 pi by 3. So pi by 2 plus cot inverse x is 2 pi by 3. Upper cot inverse x is how much? 2 pi by 3 minus pi by 2, which will give you a pi by 6. So cot inverse x is pi by 6 means x will be equal to cot pi by 6. How much is it? Root 3. So tan inverse, tan pi by 6 is 1 by root 3. Cot pi by 6 is root 3. Right? Twelfth one. Tan inverse of root of 1 plus x square minus x. Tan inverse of root of 1 plus x square minus x. What are we supposed to do? Write it in the simplest form. Okay. So you want to take x as tan theta, substitute it here. Tan inverse of root of 1 plus tan square theta. Secant theta minus tan theta. So tan inverse of 1 by cos theta minus, right? So tan inverse of 1 minus sin theta by cos theta. So if I follow the same steps, then what will I get? See, observe, we did a similar kind of tan inverse of cos x by 1 minus sin x. This is what? 1 minus sin x by cos x. So cos x by 1 minus sin x, you got tan pi by 4 plus x by 2. Upper sin x by 1 minus cos x, you will get. So tan inverse of tan of pi by 4 minus theta by 2. This is what you will get. Okay. So that will be pi by 4 minus theta by 2, or it is also equal to pi by 4 minus tan inverse x divided by 2. This is what is answer. So if you see, you have only limited set of problems that are there. Repeatedly, you will get the same thing, right? So till here, I hope it is easy. I know I'm little fast, but you have already written a test. Okay. So what problem was it? Well, what is the 13th one? Subraj, read. You have paper. Tan of cos inverse of. Okay. Is it inside itself? Plus tan inverse of. We have to prove it. We have to prove this, no? So cos inverse 4 by 5. Tan inverse of 3 by 4. Plus this I'll leave it as tan inverse of 2 by 3 only. Okay, tan of, what is tan inverse of 3 by 4 plus tan inverse 2 by 3? Tan inverse of 3 by 4 plus 2 by 3 by 1 minus 3 by 4 into 2 by 3. 3 and 3 are gone. This will cancel it 2 times. So tan inverse of 9 plus 8, 17 divided by 12, the whole divided by 1 minus 2. So 1 minus half. So this will go 6 times. So tan of tan inverse of 17 by 6 is 17 by 6. Minus 5 by 2. Open interval. This is tan of tan inverse. And if you see 17 by 6, how much is the value? That's fine. This you're finding the only inverse value of this. We need not worry about it. So what is the 14th? No? Okay. This is simple, no? Put x is equal to cos theta here. So cos inverse of this will come out as cos 3 theta. You will have 3 theta 3 times. What is that's it. So this is the 14th one. This is the problem that troubled, no? How to proceed? Okay, is there any other way you can solve this? See, if I'm able to eliminate the sine inverse, I'll be able to get the answer. So what I'll think of is sine inverse of 1 minus x. Can I write it as pi by 2 plus 2 sine inverse x? Can I do this? If I take sine on both the sides, what will I do? I'll take sine on both the sides. Sine of this one, I hope most of you have not done it, so copy it. Sine of sine inverse of 1 by x is equal to sine of pi by 2 plus 2 sine inverse x. So sine of sine inverse of 1 minus x is 1 minus x. Sine of pi by 2 plus 2 sine inverse x is cos of 2 sine inverse x. So 1 minus x, I can write it as, if I take sine inverse x as theta, for example, is this not of the form cos 2 theta? Right. So cos 2 theta, now how much is it? It is of the form cos 2 theta. So cos 2 theta, how will you write it in terms of sine? Root of 1 minus 2, sorry, not root. Cos theta is 1 minus 2 sine square theta. So can I write this as 1 minus 2 sine square of sine inverse of x? Can I write it like this? 1 minus of 2 sine square of sine inverse of x. Now observe 1 minus x minus 1 minus 2 into, it is sine of sine inverse x, the whole square. Sine of sine inverse x, the whole square. 1 and 1 are gone. So minus x is equal to minus 2 x square. Yeah. Because sine of sine inverse x is how much? X. So x square is this thing. Is it clear till this step? So minus and minus are gone. Don't be in a hurry to cancel x and x. Because you don't know what is the value of x. X can take a 0 also. If it takes a 0, you're not supposed to cancel it directly. So what I need to do is, I'll take x into 2x minus 1 is equal to 0. Observe this. What did I do? I wrote this as 2x square minus x is equal to 0. If I take out x into 2x minus 1 is 0, which implies x is equal to 0 or half. What is happening? X is equal to either 0 or half. Now, whenever you get more than one value, right, you should always substitute that value and check it. For example, when x is equal to 0, if I substitute it here, I get sine inverse of 1 minus 2 sine inverse of 0. So sine inverse of 1 is pi by 2, sine inverse of 0 is 0. So when x is equal to 0, I'm getting LHS is equal to RHS. Whereas when x is equal to half, what will I get? If I take only LHS, Sine inverse of 1 minus half minus 2 sine inverse of half. So sine inverse of 1 minus half is sine inverse of half minus 2 into sine inverse of half. So this is actually minus sine inverse of half. Is minus sine inverse of half equal to pi by 2, which is RHS? It is not equal to pi by 2. So what it means is x can take only 0 and x cannot take. I hope now you are clear. Is it clear, guys? Right. So this is the only toughest problem, I would say. Others were easy only. How many more are there? Let's do it fast. Problem number 16. Huh? Question. Okay. See, these kind of problems are important because we get them in differentiation. Okay. At that point, without knowing inverse trigonometry, you cannot touch. See, maybe the previous problem, I don't think it has an application. I'll be honest about it. That doesn't have an application anywhere else. It is only about solving it. Whereas these kind of problems, they can ask you to differentiate. Suppose they give you this function and say, find the derivative of this. You're gone. Unless you are able to write it in the simplest form. Right. So to do that, what am I supposed to do? Actually, you can directly do one thing. Tan of half into sine inverse of 2x by 1 plus x square is actually 2 tan inverse x. Property here. In both the places, you put x is equal to tan alpha, y is equal to tan beta, and then solve. So instead of doing that, you can directly use the property plus what is cos inverse of 1 minus y square by 1 plus y square? 2 tan inverse of y. Now you understood why they gave that half. So that this 2 and 2 will get cancelled. So you are left out with tan of tan inverse x plus. So that will be tan of tan inverse of x plus y by 1 minus xy. So answer will be, that's what you need to do. Is it clear? So last one. Simple, no? So convert sine inverse of 5 by 13 to tan inverse. Tan inverse of 5 by 12 plus cos inverse of 4 by 3. Sorry, tan inverse of 4 by. That is the LHS. Now apply the formula tan inverse of x plus y by 1 minus xy. You should get this answer. That part I'm leaving it. Okay. So I hope you guys got it. Right. So except 14th, and not consider any other problem to be tough. Okay. Shall we proceed to the next part? We were discussing determinants in the previous class. Right? Shall we proceed to the next exercise? So is this week also you have a tester? The week, is there a test in math? Wednesday, what chapter? Too many dates in mind. You are prepared? Huh? Yes, sir. Yeah, you're prepared. You're ready to take up. How many of you are not preparing? How many days are needed? Others are ready, Appa. Neela ready, Ada? You're ready. You continue. How will I know? You told you did. You're ready, huh? You?
I'm ready, sir, but can you keep after some time because I'm having
అది కష్టం need time na eda yosikla. Let's see, you write whenever it's possible. But others are ready, no? Can I assume? They have learned it, no? Then try writing. Okay. Shall I proceed with determinants?
Sir,
So
do we
last
have test this Wednesday?
yeah?
Sir, do we have test this Wednesday, sir?
Yes. It's continuity and differentiability.
Okay, sir.
Yeah. Okay. So last class we discussed about determinants and some of the properties associated with it, right? I hope you could solve the problems. Right. Now the thing is, properties of determinants not needed. It's not there. I think last year also it was deleted, but they asked a question. Don't worry, for that you will get marks. So 4.2 is not needed. No. Shall we try out the next one? That is area of a triangle. So I told you, where do we use determinants? The previous class I told you. Why are we even using determinants and why was it invented in the first place? Because you have a system of linear equations. Then you can find the solution of the system of linear equation using a method called as cross multiplication. And the cross multiplication method mainly takes the idea from a topic called determinants. Right? Is it not what you're doing in determinants? Also, you're doing cross multiplication with your subtracting values, right? In a similar way, the other application that you can think of is finding the area of a triangle. So I'm sure in your 10th standard, you would have learned the formula to find the area of a triangle which is formed by the vertices of 3 points that are given to you. Suppose the points that are given to you are x1, y1, x2, y2 and x3, y3. Okay. Suppose the points given are x1, y1, x2, y2 and x3, y3. Then how do you find the area of the triangle? There is a cyclic pattern you would have studied. Half into modulus of, you'll start with x1, you'll go with y2 minus y3. So it goes the pattern 1, 2, 3 plus x2. So 2 let's start with, it should go with 3 and 1. So y3, y1 plus x3 into y1 minus y2 and you will close the modulus. You remember this formula? I'm sure you would have solved many problems based on this, right? If you actually observe the pattern, right, this pattern is formed from the determinant of certain values. So how you can do that is, it is very simple. Generally, area of a triangle, in this case, they are represented with delta, but you just go with area because delta is mainly used for determinant. So half into, this is not modulus, it is determinant of x1, y1, 1, x2, y2, 1, x3, y3, 1. So if you want, you solve this and see, you will get the same cyclic pattern. Right? So if 3 points are given, this is how you need to find. Okay, there are certain remarks that are given to you. When you try to calculate the area of something which is formed by the vertices, you should always take the absolute value. What do I mean by absolute value? You should always take the positive value. Right. So once you find this, sometimes determinant might come out as a negative value also, but you need to take the modulus of it. Secondly, then if the area is given to us, listen to this. This is a reverse process. You find determinant and you want to write the area. If the determinant comes out to be negative or positive, you will only report the positive value of area. Whereas, if area is given to you and they're asking you the determinant, for example, area of a triangle is 27 square units. Then 27 is equal to half of determinant of this. Then what is determinant? It is 54. No. When you're reporting the determinant, you should write it as plus or minus 54. Because how did you get that area? By taking the modulus. So you don't know whether the determinant is exactly negative or exactly positive. Okay, that's what they've given in the second point. If area is given to us, both negative and positive values of determinant is supposed to be used for calculation. Third one is, obviously the area that is formed by three collinear points is always 0, because it does not form a triangle at all. Right? So these are the 3 points to be kept in mind with which you can solve all the problems. Shall we try out? Right? Can you guys try doing it? 17th one. Find the area of the triangle whose vertices are given. Find the area. So find the area. Don't use a formula. Use determinant. Determinant C. Yeah, determinant formula physics take the time. 1, 2, 3, 4, 5, 6, 7, 8, 9 and recognition. Upper 1 la arambikirana 1 into what will you do? Cross multiply. 45 minus cross multiply. 48. Minus 4. Physics la pannirukalla idu. Minus 2 into 9 into 4. 36 minus 7 into 6. 42. Plus 3 into 8 into 4. 32. 32 minus 35. I hope everybody got the answer. So did you get the positive value of determinant or negative value? Positive then leave it. So you got 61 by 2. Just add a term called square units. 61 by 2 square units. Okay. Next one. Find the equation of line joining the points. Find the equation of line joining the points A1, 3, B0, 0 using determinants. And find K, which is given by the point DK, 0 is a point such that the area of the triangle ABD is 3 square units. In this case, what have they given? The area of the triangle is given. Okay. Then you need to find the equation of the line joining A, B, and C. Oh, sorry. There are 2 points actually. Listen. Find the equation of the line joining A1, 3, B0, 0 using determinants. Okay, how will you find it? So for you to find the equation of line, you need a locus point. So let the locus point C be x, y. So you need 3 points, 2 given points, and third one. So you need x and y, no? Where? They are fixed values 1, 3 and 0, comma 0. You need xy, no? You need a general point on the line, no? That's called locus point. You can do it, but what did they mention? Using determinants, I know what you're doing. You're doing y minus y1 is equal to m into x minus x1. That you can do. But that should match with the value that you're trying to find using determinants. So I need a third point. What have they given? So since A, B, and C all lie on a straight line, what is the area formed due to it? 0. So half into what I can do 1, 3, 1, 0, 0, 1, and x, y1 is equal to 0. So 1 into what will you get? Minus 5, no? Minus 3 into plus 1 into 0 is equal to 0. So 3x minus y is equal to 0 or y is equal to 3x. That is obvious, right? Because a line passing through the origin and you know the point, y is equal to mx. M 3. So y is equal to mx is what you will get. So what you can do is once you find the using determinants, try to validate it using straight lines. Y is equal to 3x. Okay. Now, if you have a point D which is k comma 0, such that the area of the triangle ABD is 3 square units, how to find the area of triangle ABD? Half into A is 131, B is 001, and D is K01. And how much is the area given as? 3. So determinant of 131, 001, and K01 is equal to 6. Then find the value of K from here. For the answer, K is equal to plus or minus 2. Right? So can you solve the remaining problems? Can you do it fast? So first, find the area of the triangle with the vertices at the given point in each of the following. So you're able to do. So what is the answer for the first one? Fifteen by 2. 1, 0 and 6, 0 both are on x-axis. The midpoint of 1 and 6 is 15 by 2. Okay. What about the second one? 47 by 2. Okay. Third one. 1, 5. So for everything, add the term square units. Those are online. Are you doing it?
Yes, sir.
Okay. Second one. Show that the points capital A given as A comma B plus C, B as B comma C plus A, and C as C comma A plus B are collinear. Okay. Yes. In your 12th standard, right, you should not use the concept of slope. If they ask the same question, don't use the concept of slope. You need to prove that the area of the triangle formed is 0. So what is the area of the triangle formed? A, B plus C and 1, B, C plus A and 1, C, A plus B and 1. Okay. So A into what will you get? C plus A minus B. A and A will get cancelled. Minus of B plus C into B minus C. Plus 1 into AB plus B square minus AC minus A square. Okay. Here you are getting AC minus AB minus B square plus C square plus AB plus BC minus AC minus A square. Did you understand what I did? Is there anyone who's confused? AC and AC will get cancelled. AB and AB will get cancelled. B square and B square are gone. I'm getting C square. Engada?
Last one would be equal to AB plus B square minus C square minus
Here this C square. 1 into, tell me again.
AB plus B square minus C square
1 minute. 1 into AB plus B square
minus C square.
minus A square. Oh,
So minus AC.
okay, got it. Minus AC minus C square. So AC and AC gets cancelled. C square and C square are gone. So you're getting a 0. Hence, the points are collinear. Find, if you read the question, third one itself, they're saying find the values of K. Means you will get 2 values. Find the values of K if the area of the triangle is 4 square units and the vertices are K0, 4, 0 and 0, 2. Okay, do it fast. First one is 0. Correct. Second one, 8. Check it again. Eight, plus or minus something. No, you when determinant is when area is given for determinant, I told you, you should use plus or minus. Is it plus or minus 8? Is there anyone who needs my help? You want me to do, I'll do it. If you're getting stuck, please ask. So can I assume everyone is clear? Okay. So for third one, if you see 2, half of determinant of minus 2, 0, 1, 0, 4, 1 and 0, k1 is equal to 4. So this one, can I write it as 8? So minus 2 into 4 minus k minus 0 into something plus 1 into 0 is equal to 8. Okay. So this will cancel it 4 times. But what am I supposed to do? I need to mention it as plus or minus 8 because I don't know whether the determinant is going to come out as a positive value or a negative value. So I'm not cancelling this 2. So I leave it as minus 2. So minus 8 plus 2k is equal to plus or minus 8. Is this what you got? Okay. So you take minus 8 plus 2k is equal to minus 8. Then k is 0. Whereas when you take minus 8 plus 2k is equal to plus 8, then k is equal to 8. So the answer should be either 0 or 8. The reason I asked you, when you told me the answer for the first time, I asked you to check it again. You know why? What are the points? Minus 2, 0. So minus 2, 0 is here. And what is this point? 0, 4. So for the area of this triangle to be 0, then what should happen is I should have half into base into height. If I see the base, this is 2. If I see the height, it is 4. So 2 into 4, cancel it, that will give me 4, provided one of my points is origin. So that is why I thought the only option for k is 0. But we are getting it, you are able to understand. So if I put k as 0 here, I'll get origin as one of the points. If I put k is equal to 8, I'll get another point over here. 8, 0, then you will join this one. That is the other triangle. 0, 8. Correct, 1 minute. So if it is 0, 8, then it should be like this. This area is also 4 units, 4 square units. Is that clear? Right. So can you do the 4th and 5th? With that we are done. Can you do it a little fast? So find the equation of the line joining 1, 2, 3, 6 using determinants. So let the third point be x, y. apply the determinant and equate it to, so you'll write half into determinant is equal to how much? 0, because all the three lie on the same line. So for the sake of cross verification, you can use the formula y minus y1 is equal to m into x minus x1. Here, first one. Those who are online, I hope you could understand. Yeah. Hamsini, Harini, Harshavardhan, Harshita, Nitinanand. Are you guys clear?
Yes, sir.
So just now
Sorry?
you were on mute the whole time, sir. When you left the mute.
I was on mute.
Yes, sir. Like after you left the mute, you were on mute.
I didn't leave actually. There was a network connection. After that, I logged off and I thought I was audible. But like you understood now how to solve. I didn't teach anything. It's about exercise 4.3. It is about exercise. I hope it is clear. Yeah. Okay. That's it. We'll wind up this.
Sir,
Yeah, tell me.
sir, shall I take chemistry test on coming Thursday? The day I didn't attend chemistry test.
I'll tell you, Ma, because papers will mostly get corrected. Can you take it as an assignment and do it?
Okay, sir.
Okay.
Sir,
Yeah, tell me.
sir, Saturday do we have test, sir, physics?
I think I already shared the schedule. I told you I can't remember like that. I've given the schedule to you. Just have a look.
Yes,
at
sir,
it.
it was there in the schedule, sir, current electricity.
Then it will go. Then it will go as per the schedule.
Okay, sir.
So that's it, right? We can wind up.